Okay, so it finally works, and it took like forever. I'm like 3 weeks after schedule, my dream schedule anyway for this vehicle, and the main difference this time compared to the previous tests is that I have separated the ground. So I have 3 PWM systems, one controlling the inflating system with the 2 vacuum cleaners, and one for the right side of the vehicle and one for the left side of the vehicle. And earlier they shared ground, and it turns out, you can see my oscilloscope is not here because I've been using it a lot in the in my workshop to try to chase down the problem, and I've burned a couple of transistors during that time as well. But it turned out that it's a lot of noise in the system because it's a simple hack. So it's really a brute force sort of solution I'm working with. So the inductiveness of the motors, and when running them with power turned on, not just testing the PWM system with a resistor or something like that, but actually doing this live. There's too much noise floating out from one PWM system, and it finds its way to the gate leg on the other transistor arrays, and under certain condition they interfere so much so that you actually destroy the transistors. Well, the thing is, last autumn I did a test in the garden, when I spun around the pole. So I had the same battery bank powering both the vacuum cleaner that inflated that tire and also the traction motor, and so it was 2 separate PWM circuits, and the negative terminal of the signal was connected to the main ground of the main battery pack. And I was simply lucky that time, and I do not like to be lucky, because luck just keeps you ignorant and you don't know what's really going on. It makes you blind for alternative solutions and alternative problems that might be there. So I was just lucky that the inductance of the vacuum cleaner motor used at that time did not interfere with the transistor used for the traction motor at that time. But this time it did interfere, so I could see a lot of spiking and noise, despite, of course, I'm having a flyback diode, but that's just a bare necessity. Without it you will burn your transistors immediately, but it's not enough to dampen the noise in the system. So that's the main different this time from previous time. So I'm actually having 3 separate battery banks, one for the inflating system, and that's a good thing, because then I really can predict how long I can keep the tires inflated, and it's like 3-4 hours, so that's very good. And now I have two more battery banks, one for the right side and one for the left side. And that's not as bad compromise as you would think, to have 3 separate systems, because the price point of lithium battery cells, around 5 amp hours. I don't have one right here right now. But the price point for those battery packs are pretty much optimal. You get as much capacity for the money as you can. So I really do want to stick to 5 amp hour lithium cells, and to get a relevant range of the vehicles, say that you want to be able to go at least like 10-15 kilometers or so, you really need so many cells of the 5 amp hour type, so that you have enough voltage to create 3 separate battery packs anyway, instead of connecting them in parallel. I have them separated, so it doesn't affect the range, and it doesn't affect how cumbersome the charging will be or the handling of the batteries. So it's just a kind of small compromise to get 3 separate ground levels for the PWM system to work with, so that I don't have a ground that's floating around and distributing noise in the system. So I'm good with that solution. But I have made so many different, many other updates on the vehicle, so I just have to show you on the vehicle itself. So let's take a closer look to what's new. Okay. And again, let's go from the front to the rear. So I've just added a temporary wheel here to be able to take it out myself in the garden, since it's a lot heavier now with the all the batteries installed. And right here in the very front you can see these clamps, and it's a result of me ditching the threaded rod solution for connecting the front and rear axle to the chassis, and that rod actually worked as a electrical path because it was threaded in a aluminum disc inside here, which is fastened with screws. So electricity could go from this part all the way to the rod sticking out here and into the front axle, and I use the aluminum structure as a return path for the 12-volt current going to the relays, which are positioned in the wheels. So without that threaded rod, the front axle was electrically isolated from the chassis, and I needed to make that return current go somewhere. So I added these 3D printed clamps, so I can clamp it on to the front axle and reinstalling, so to say, the electrical path for the current going from the relays, from the coils in the relays. So that's what this is for. And here you can see that I have made the temporary fix last time for assembling the vehicle a part of the system now. So this cargo tightener here allows me to winch in the front axle and the rear axle as well. I have another one in the back. So I've dropped the threaded rods and gone to this system, and it works really well. You can see here that the assembly time is extremely much shorter this time. And then we have the battery connectors. I'm using the same type of 3D printed parts as in the multi-rotor. So the batteries are connected to these connectors here. So they are 14.7 volts each or so at this time. And as soon as I attach this and screw it onto the connector here, I have 240 volts coming out from this one. So the batteries are not in series when they are at rest. And I have 3 of these, of course, because it's the right side and the inflating system, and the same one for the left side. So they're 3D printed and they work really well. They're of course solidly 100% infill in these plastic parts, so they're quite rigid. And I'm using a polyurethane glue to fasten these XT60 connectors into that. And if we move on here, you can see, well, it's the same screw down action for increasing power to the inflating system, but I have added here, since I have 3 circuits now, I could not have just one circuit breaker, so I have 2 separate circuit breakers for the left and right side, and these are you just pull them up, and it's an XT90 connector here, and it's a 40 amp fuse in here, so they are fused as well. So if I pull out these, I disconnect the battery from the transistor arrays and from the motors. The inflating system does not have a quick unplugging system, simply because if it goes full power, I will still have time to unscrew this. So it's not as a acute problem as if the traction motors go flat out, full speed. So I have for that system I have this quick release, and for the inflating system I simply have to unscrew the main connector there. And on the back side nothing is new except for the cargo fastener, which is secured onto the chassis there. Let's take off the upper part of the vehicle. So here you can see the current state of this vehicle, and I'm using my old battery pack for the utility vehicle here in the middle. So they are the old green multi-star cells, 5.2 amp hours, and I'm using two other sets of 5 amp hour batteries for the right and left propulsion system or traction system. And as you can see, there is a lot of wiring, so that took a couple of hours to solder all that, but now it's done. Since I choose to reuse these multi-rotor connectors, I had to drop one batteries. Previously I had 16 4-cell batteries, which gave me a 268 volt fresh of the charger voltage, but since these only have 15 ports, I dropped one battery for each traction battery bank, so I'm down to about just over 240 volts when I'm fresh of the charger. But that's okay, because the motors are rated for 240 volts, so I was slightly overvolting them in previous test. And the battery bank for the vacuum cleaners actually lost yet another cell, so they are 14 cells powering the vacuum cleaners. But since I don't run them full throttle anyway, I don't think that's a big loss. And it's just under 1 kilowatt hour of battery pack for each of these 3 subsystems. I have yet to solder the balance leads, so that they can go out to a quick connector as well, so I can charge them easier. But I didn't want to do all that work before I knew that I have a functioning system. And here you can see the XT90 connectors, and here's the PWM system for the inflating system. And right now I'm using pretty significantly heavy-duty MOSFET transistors there with screw-on connectors, and I have 2 on this side. I just wanted to see if one was enough, and it seems to be good enough. It's continuously 80 amp, and I think like 300 amp in a 300 microsecond pulse, and it's repeatable. And I have one of these as well for the vacuum cleaner motors. It's way over rated for that, but there it is anyway. And here, let's take a closer look at the transistors I'm using right now. So it's a so there it is. It's a 500 volt 80 amp continuously N-channel MOSFET perhaps. Oops. And they're pretty hefty. There are 4 connectors. Of course, there's a gate and a drain and a source, and then it's a Kelvin source as well. I really didn't understand the point of that, but anyway, I'm using 3 of them, and the Kelvin source connecting part is just left as is. So these hefty buggers are doing the chopping, and it looks like one is good enough to control the current to 2 motors. Although I did not run the vehicle fast this time, I think it's a pretty decent stress test to turn it like a tank, like I did in the garden. And the friction under the wheels was kind of different. It was of course low friction where there was snow, but where it was more muddy and grass, I think the current probably shot up pretty good. So I think that they have proven to work, at least in this first testing phase. Since I'm obviously in a very early stage of testing things, I'm actually testing several things at the same time to find out what's the best solution for the power system here. So on this side I had just one of these powerful transistors, and I have 3 100 ohm resistors connected in parallel between the gate and the source, so it's 33 ohms. And I have a around 2.5 ohm, it's actually 4.7 ohm resistors in parallel, so it's like 2.35 ohms coming from the PWM system hack in the electric drill hack going into the gate, so it has a gate resistor as well. And the other side does not have a gate resistor, and it is a little bit more spiky when I'm checking on the scope. since the turn on is so fast. But it's the same 3 parallel 100 ohm resistor between the gate and the source for each one. So this one will draw more current in the PWM mode, so it will drain the batteries a little bit quicker than the other side. But if this holds up well, I will of course remove one of the other transistors, because it's just a unnecessary power consuming setup in that sense. And in an effort to make the front wheels inflate as fast as the rear wheels, I opted to relieve, to create a lower pressure path for the hose. So instead of having it bent down here, I 3D printed a part, but I wasn't sure if that was enough, so I actually added restrictors to the rear wheel hose. But that was obviously too much, because as you can see in the video here, the rear wheels did inflate a lot slower, so I had to open up this restrictor to make it more even. Well, actually, I'm thinking about 3D printing restrictors and place them on the hose out here with a sort of restricting screw, so that I can adjust the amount of air flowing into each wheel, because they seem to be slightly different always, so that I can find a setting that is optimal, that makes the wheels inflate evenly. And the testing you just saw was a unedited test, and it was the first test where it actually worked. And these batteries were fully charged yesterday, so they were sitting overnight. So they were 4.2 volts each cell last night. And let's just see how much I have discharged them during this short test. I'm just taking a random battery here. So 4.15, 4.18, 4.15 and 4.19. So pretty much what I could hope for. They're almost completely full still, and that makes sense, because it was just a short brief test this time. The same there, 415, 417, 415 and 419. So that seems promising. Really minor current draw from this test. Let's see here if I can make that happen as well. Okay, so on the other side here, I also have 415, 418, 415 and 418. Yeah, that's good. So almost fully charged. And over here you can see it's a similar solution. I don't know if I can take it off. No, I can't. It's a XT90 connector here with a small fuse attached to it. It's for the inflating system. It's just like a last defense for safety. So simply it helps the wires not to burn up. Of course it won't save the transistor, but it will prevent the insulation of the wiring starting to burn if I got some sort of short circuit here. And here is the flyback diode for the right side, I think it is, of the traction system. It's a pretty hefty diode, and I have a similar one on the other side. For the vacuum cleaners I have a smaller diode. Actually there are 3 in parallel. They're not supposed to be connected in parallel, but I did that anyway. I got away with just using one, so I don't think it will hurt to add yet 2 more. But it's sort of silly thing. I think I should remove 2 of them, because they will not work very well when coupled in parallel like that. Okay, so next step is to print out the check valves for each hose to each wheel, so that I can make the inflation process more evenly and achieve a better even pressure in the tires also when it's inflated. And I will take it out for a more proper test ride out on a local grass field, so that I can find out the the handling characteristics when I'm running it a little bit faster. And I'm really looking forward to that. I hope the weather will get a little bit better. Today was kind of windy, and it was not that pleasant to be out today. And eventually, of course, I will connect all the balance leads to a sub-D connector so that I can use my charger array to charge up the battery so it's less cumbersome. And I will get to that eventually. And I think, well, it's really about just test riding the vehicle a little bit harder to see if I can break something, and I'm sure I can do that. Also, one wheel, the first wheel that I made, has a single seam outside. All the other one has a double seam. They're all sewn with a just ordinary household sewing machine, so they're sort of weak anyway. But I really need at least a double stitch to make it well, seem more appropriate anyway. So I will do that also, depending on how the weather is. Probably not right now, but it's a thing in the pipe anyway. But really, I'm just looking forward to ride it again and take it out a little bit more, both speed-wise and try to drain down the batteries a little bit more and find out about how much it draws. And I'm thinking about having some sort of app turned on so that I can see the distance that I'm driving, just to get a feel of the potential range of this vehicle. So don't forget, please subscribe and stay tuned for the next episode.